Okay, so the idea now is to look in operating systems on a synchronization method, which is the semaphore. Semaphore is like a lock that depends on the count of the semaphore. It can count more than one. It let some amount of processes get into a critical section. Now, think about a mutex, which is a lock. Now, mutex only let you enter one process into the critical section at the same time. All the idea of those synchronizations like semaphore and mutex is to prevent a condition racing in which too many processes are using resources such that they can change the resources that may cause problems, like one process change a resource and in the middle another process change it, and then they save and we have two options from the same resource and we don't know how to save it. It depends who work on the resource first, and we can have many problems with it. So in the critical section, we let only the amount of resources we can use simultaneously, or we can let the amount of processes that you can let work simultaneously on shareable resources. For example, if we have two resources, so we can let two processes simultaneously get into the critical section. The critical section is the area in which we modify or work on or get access to shareable resources that can cause problems if too many processes work on them simultaneously, race conditions. So semaphore can have a count, and each process that get into the critical section down this count, reduce this count, and when this count gets to 0, then any process that want to get into the critical sections becomes block. Now, to reduce the amount of semaphore we have, there is a function which called wait. A process that want to get into a critical section, do the wait function, reduce the semaphore. If the semaphore already 0, so the process, when it tries to do wait, cannot get into the critical section. But if, for example, the semaphore count is 3, so it reduces the count from 3 to 2 and get into the critical section. And then another process can do also wait to reduce the semaphore from 2 to 1, and then another one from 1 to 0, and then another one cannot reduces anymore from 0. So we just wait until some process finish in the critical section. When a process finishes in the critical section, there is a signal. He uses the function signal that increase the amount of semaphore, increase it from 0 to 1, for example, and then a process that waits, you see that there is a wait in queue, can get into the critical section. Now let's see how it works. Let's just make 5 processes and 3 semaphores. Let's do even 4 semaphores. So we have 4 resources available. If we are doing 2 semaphore count 2, we have 2 resources available. So it depends on the count we give how many resources is available. Let's start with 3 resources and 5 processes. Now the semaphore count will be 3 because we have 3 resources that are available. Now you can see that inside the critical section, we can just let 3 processes inside and not anymore. Any other process we want to get inside need to go to a wait queue till another process ends. Because you see that we have 0 available resources, we need someone to end, and just when he finishes, just then the available resource let another process get inside. So this is the idea of semaphore. It's like a counter until it locks the critical section. Like a mutex, but mutex is just like 0 and 1, like a binary semaphore. But semaphore can count more than 1. If I have more than available resource, more than 1 available resource, I can use semaphore to let some process simultaneously get into the critical sections that uses those resources, those shareable resources, or shared resources, if you want to call it. So this is the idea of semaphores in operating system, in synchronization in operating systems, and the idea of them. Thank you very much. If there are any mistakes or corrections, please tell me. And let's just do another example. For example, I can use now 2 semaphores with 5 processes. So I have count of semaphore is 2, so I have 2 resources. So you can see here that only 2 processes can be in the critical section, and everyone that wants to get inside need to be in the waiting queue. Okay, this is the idea of the semaphore. Thank you very much. That's it for now.